Now it's time to develop a load generator. To do this, we will correlate the architecture presented earlier with the final release of the project, learn how to assemble the project using SBT, and will execute debugging runs in the development environment. First of all, you need to go to the corresponding folder and analyze the source code of the load generator. The main configuration file for building the project is build.sbt file. It consists of various stages. First of all, we connect all the necessary plugins: Gatling SBT and SBT assembly plugins. Next, we specify which version of Scala we need to use, the name of the final jar file, various parameters and libraries that need to be downloaded, as well as two tasks that define how to work with resources. Some of the resources remain inside the jar file and some outside. Now let's open the src Scala directory, and we see the Gatling runner object that we are already familiar with. It is used to run the test scripts directly from the development environment. Loading the test object from the development environment is carried out as follows. After starting the Gatling runner configuration, the corresponding simulation is executed. Simulation contains a scenario. In this case, a scenario has been selected for testing the eShop online store as an open model. Next, open the scenario package and see two scenarios for testing the eShop object as an open system and as a closed one. Both scenarios are organized in a similar way. First, the protocol that will be used to connect to the online store is specified. It will be the HTTP protocol. Next, a scenario is created using the scenario creator object, and a chain of requests is specified that will be called in this scenario. Then, the inject open model method of the scenario injector object is called, and this method allows you to put users into work according to the logic of testing open systems. Now let's move on to the request chain that is passed to the create open model scenario method. We can see that the chain consists of requests that are already familiar to us. First, the index page is called. Then, getting categories, getting products, adding a product to the cart, and so on, until we call the order confirmation method. The requests themselves are stored in the requests package. Let's analyze their internal structure. These objects are written in a similar way. The names of the methods speak for themselves. Methods that work with HTTP protocol are used. First, the name of the future request is specified. For example, for a request to get an index page, the name of onGetIndexPage will be used. After that, the request method is specified, as well as various headers. Then the request is sent and we can process the received response. For example, in this case, we expect the response code to be 200, which indicates successful processing of the request. The same is for each request. For example, a get method is also made for the get categories request. The code 200 is checked. The JSON format response is checked for the existence of the categories object. The contents of these objects should not be empty. And the number of categories should be equal to 6. After that, the category ID is saved to a special variable. Next, products for the category are called. And the contents of this object are similar to the previous ones. A GET request is also made, but in the address bar we see the variable categories random. This means that the category ID is randomly selected from a variable that was created earlier. After receiving the response, the code 200 is checked, and the received products IDs are stored in a special variable. Next comes the adding the selected product to the cart. The post method is used, and the function that fills templates with variables is called. Let's find this template in the resource folder and open it. And here the product ID is randomly selected from the previously created products variable. After that, there is a repeated request get category products, as well as another adding the products to the cart. Next, we get information about which products were added to the cart in the previous steps. Then a GET request is executed, and all the necessary information about the products in our cart is saved. Along with the JSON path handler, you can find JMS path. These handlers perform the same function, run through the JSON and get the necessary values, but use different syntax for this. Next step is to increase the number of products in our cart. This happens as follows. Before executing an HTTP request, we call the setSession variable method. It randomly sets the amount by which the product needs to be increased. And also the ID of the product is randomly selected, the quantity of which we want to increase. The values of these variables are passed to the virtual user session. And the randomizer object is responsible for their generation. These values can be just numbers, as well as names, emails, addresses. After that, the HTTP method is called. The answer is checked for the code 200, and also that the quantity of the product has been increased by exactly the value that we set earlier. Then the information about the cart is received again. And then the user makes a request to confirm the order. First, various values are randomly generated and passed to the session. Then the values go into the template, fill it, and the request is being sent to the test object. In the received response, the generator checks the code that should be 200. After we launch Gatling Runner, these things will happen. First, the variables will be read from the configuration file, and their further initialization will be performed. The configuration file is located in the resources folder and is named as application.conf. It specifies the following parameters. This is the address to send request to. The ramp up duration means parameter means that we will inject virtual users into work gradually, linearly, within 5 minutes. And then there is a steady state duration minus parameter, which defines the further duration of the test. The user injection for the remaining period will depend on the selected testing model. With an open model, users will be injected into work with a constant rate, and with a closed model, no user will be injected because they all have been injected earlier. The user's rate per second parameter defines the rate of user injection per second used when testing open systems. And for testing closed systems, the parameters, the number of simultaneously working users and the period of actions are used. We also have a gatling.conf configuration file. This file defines the methods for displaying statistics. For example, we will output to the console a file and over the Graphite protocol. And another configuration file is logback.xml, in which login levels are set. And there are also two files with extensions bat and sh, which run tests on Windows and Unix-like machines. Now it remains to learn how to assemble our project. The project is built using the assembly command, but it must be run from under the load generator directory. To do this, create a new configuration. Select SBT task, name it as assembly from load generator, the assembly command, and set the directory from which it needs to be run. Launch it. The command started executing, and now we should see that the disk directory has appeared, into which the corresponding resources are added. Yes, it is. The resources have been copied now. And now we are creating a jar file, which is our load generator. The task was completed. The generator has been created, and in the future we will copy it to the remote machine using Ansible. And now let's learn how to run a scenario from the development environment. To do this, we previously have created the Gatling Runner configuration element. We know that Gatling Runner calls open model scenario. It remains only to start it. The scenario is already in the process of launching. First, the parameters are read from the application conf file. Requests will be sent to the specified address. The test has already started, and 7,499 virtual users are waiting to be injected into work. And as we can see, users have started to send requests. So far, all requests are being completed successfully. This is evidenced by the OK column. A percentage scale is displayed at the bottom, by which you can understand how much is left before the test is completed. In total, the test will last 15 minutes, and the rate of user injection will be 10 users per second. We have made sure that everything is working properly, and at this stage, the test can be stopped.